We are going to construct and view a simple tree. We're going to do this in code, but before I code it, let me explain what we're doing here. So we want to fill every node until we reach the maximum possible node number that is specified. We're basically going to add nodes into this binary tree until we want to stop. And I stopped at 9 just because on level 4 I kind of ran out of space to keep going. But this is a sequential tree. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have them all kind of in order as going this way. And then, of course, down. So this is our sequential tree. It's very basic, but it's going to get the point across very well about how to add values into this tree. To do this, we are going to use recursion. Typically, whenever we deal with tree methods, we use recursion. We're going to also use a public member, and we're also going to use a helping private member. This first public method is actually going to be a constructor, and this constructor is going to be for our int tree class. If you don't remember, we've previously made this class int tree node. We have 3 values in it. We have a data and then a pointer to a left and a right. We have 2 constructors in here to initialize the data values. We then have this class int tree where we have a private int tree node. This is our overall root, which is going to store a bunch of these int tree nodes inside of it. Previously, we've just written out these print statements for pre-order and post-order, but we need to add into here. And so to add into our int tree class, it makes sense to do it in a constructor. That's why what we're going to be coding is a constructor. This is just pseudocode. We're going to get into the actual code in a second. But we have this public. We are going to want to call it an int tree because that's what our class name is. And then inside of here, we're going to want to take the maximum value that we want to create this tree up to. And then we're going to set the overall root equal to our private method, which we'll just call buildTree. So inside of here, we'll just have a private buildTree. And it's going to return a int tree node. And the reason why it's going to return an int tree node is because that is how we are going to make all of our connections with this class int tree node, because it has our data and it has the pointers to the left and right. So with that known, let's keep coding for this. We have this public int tree node. So with that, let's go back to our method. We have public int tree, we pass in our int max, and then we set our overall root. That's the only variable in our int tree class. We set it equal to build tree, where we should pass in a starting value. So we'll pass in 1, and then we're also going to pass in our max value. So the parameters inside of here are going to be our n starting value, and then we're going to have the maximum value in here. It's pretty well known that you need a base case for recursion. So if you want to make a base case for recursion, it should be running this until we reach the end. But when we reach the end of this tree, we're going to have null values. So we're going to run this as long as our n has to be less than our max. So if n is greater than max, then we are simply going to want to return a null value. Otherwise, we're going to do some recursion. Let's do this in priority of looking at the left side, and then we'll go and we'll look at all the right sides. So first, let's go and recursively look at the left. To do so, let's make a new int tree node variable. We'll just call it left. And we're going to set it equal to, this is where we have the recursive part. So in our recursive part, we are going to recursively call this same method, buildTree, and we're going to pass in our max. That's not going to change, but we need to pass in a new n so that we can eventually hit this base case if statement. Well, how do we do that? The way we could do that is by having our n change, right? It's pretty obvious. But how do we change it? Well, if we look over here, we can see that 1 multiplied by 2 is going to give us 2. 2 multiplied by 2 is going to give us 4. 4 multiplied by 2 is going to give us 8. So to the left, it's going up by 2n. So we can pass in 2n. This is going to be our left. So we're going to recursively go in here. We're going to get a 2. We're going to go in here. We're going to get a 4. We're going to go in here and get an 8. And the way this would work is our first call, n is equal to 1, and we're going to go into this left recursion. That means we're going to have a n is equal to 4, and our max is still going to just be the max. So I won't write that here just for simplicity's sake. And then we do this again. We have n is equal to 5, and then we have n is equal to 8. And then we'll go into this recursion one more time. we are going to have n is equal to 16. Now this is going to be in our if statement right here, because n is now greater than max, we need to return null. So the return for this is going to be null. So now what we've just done is created a link. We have our 1, we have our 4, we have our 8, and we have a null. Remember, these leaf nodes do branch out to null values, so we do have to set these to null. So after this is null, we should go to the right and have a null here. So let's go in here and make a int tree node, and we'll call this right, and we're going to set it equal to the recursion again, where we have buildTree, and then we're going to pass in 2n plus 1 in max, because if we look to the right value is 2n plus 1, whereas our left was just 2n. So after we do this, we're going to have the null value right here. We would then want to return to the previous iteration of our loop. So we would want to go back up here because this is all done, right? So to do this, we are going to want to have a return statement in here, and we want to return the relative root, which is our 8. So we're going to want to return a completely new int tree node, and we're going to use those constructors that we made previously, and we are going to pass in the relative root value. If we unwind, it'll be an 8, so that's going to be our n, and then we pass in our left and our right, which is going to be null for this example. And then once we do that, we are going to return to the previous recursion, and we're going to be at this 4. That's going to be where we went in right here. We have to go down to the right, so going down, we are going to have the right be 2n plus 1. 2n plus 1 is just going to be 9 in max here. That's what's going to give us this 9. And then we're going to recursively go into this again, right? Because we call a new build tree, and that's going to be this private right here. And so going through this recursion again, we hit our else, which is initially this left. We do the left, it's going to give us a null. We do the right, it's going to give us a null. So we're going to want to return 9. So we return back up to this 1. Now, returning back from this 1, we are now in the initial run through of this method. We stopped at the left of it. Now we need to keep going to the right. Going to the right of this, 2n plus 1 is going to give us a 3. And then we have to, since it's recursion, we go through this again. So we're in this else statement again. We're in this int node left. So going to the left, we are going to get a 6. Then we have to go through this recursion again because we call it buildTree again. 6 with 2n is going to give us greater than our max. So this is null and this is null. And that's what we're going to return back up here. And then we have to go to the right. So we're going to go down here. It's going to be 7. And then we check this is null, this is null. Then we're going to go back up to our 3 and then back up to our 1. And now every recursion is complete. We can then return our new int tree node, which is going to store everything we have in here. Hopefully that made a little bit of sense. If not, that's okay, because now is the time where we are going to start coding it. We're going to do so in the int tree class. Since it's a constructor and then a private method for it, I'm going to do it right underneath the first variable. It's going to be a public, of course, int tree. Inside of here, we're taking our maximum value as parameter, and we want to set our this.overall root, and we're going to want to set this.overall root equal to the build tree method that we are about to create, where we pass in our max. So going down here, we need a private. It's going to be build tree, and we're returning an int tree node. And then inside of here, we're taking 2 parameters. We're going to take our n value. We're going to take our max. That makes me remember we need to put a 1 inside of here because that's where we're just going to start. Make sure you spell everything correctly, and then make sure you put the variable types in here as well. All right, this is our header and this is our constructor all done. Let's code our base case first. So this is going to be if our n is greater than our max, then we don't want to do this anymore, and we're just going to want to return a null. This means we're at the leaf of our tree. Otherwise, this is going to be where all of our recursion happens. So first we want to make the left, and then we want to make the right, and then we want to return the current or relative roots. Remember, there's only one overall root, but every time we go through this, we kind of have a new relative root that we're looking at. So first with our left, let's do this recursion. We are going to make a new int tree node. So int tree node, we'll call this left, and we'll set it equal to build tree. Now the n that we're going to pass in, remember it's 2n, and then we are going to keep our relative max. That's pretty much going to be it. This should also be 2 times n. For our right, it's going to be pretty similar. I'll copy and paste this actually, so you can see how similar it is. So putting this in here, all we need to do is change the name to right, and then make this a +1. And that's pretty much it. Recursion is pretty simple in itself. And then we want to return the current root. So returning the current root, we're going to return an int tree node, where we're basically just returning the original root with our links to the left and right. We are going to we are now going to return the overall root. So we're now going to return the overall root with links to our left and right. So we want to return a new int tree node, and we are going to pass in our n, which is the original n, and then we're going to also pass in the left and right, which now has all of our links. So that is the code, and that is the way we would pseudocode and explain it. If you have any questions on constructing and viewing a simple tree, please let me know in the comments below. And if you want to see more Java binary tree stuff, check out that playlist link below the like button.